All right, so question 7 is something that doesn't even really immediately appear to be related to the mean value theorem, and it can be actually answered without considering it. Let f be a function that is differentiable. Of course, then that means that it's what? It's also continuous. And it's smoothly connected everywhere, and there's no vertical tangents. Suppose that f of 0 equals -3, and f prime is less than 5 for all values of x. How large can f of 2 possibly be? What's its maximum value? So this one, you could just kind of think about what the graph would look like. Here's 0, -3. Yeah, now if you want to know what the biggest value we can have at x equals 2 is, here's 2 right there. This piece tells you that the derivative is less than or equal to 5, so that tells you then that the maximum what is 5? Slope. So if you want to find the biggest possible value for 2, all you have to do is come to the starting value and go up at your maximum allowable rate all the way through the problem, and that'll bring you to the highest possible point at 2. So if the maximum slope is 5, all we got to do is go up 5 from -3, that puts us at 2, and over 1. So we're now at the point 1, 2. We'll do it again. We go up 5 to 7, and go right 1, and that puts us at 2, 7. So it would appear that the values f of 2 can be equal to 7 or smaller than 7. Because if you went up then at any rate that was smaller than 5, you would fall short of the 7 at 2. That's one way to do it. So we could answer the question then, the max value of f of 2 is y equals 7. But sometimes it's not going to be real intuitive, or we have to span a lot more x values than that, or we're going backwards. So there should be an easier way to do it, and here's the way to do it. Using the mean value theorem, it tells us that f prime of x is equal to f of b minus f of a all over b minus a for a differentiable function, right? And because it is differentiable, we know it's going to be continuous on the closed, differentiable on the open. So if we kind of fill in what we know then that f prime of x, since I want to know what f of 2 is, and I know f of 0, I can set it up as f of 2 minus f of 0 all over 2 minus 0. And because f prime is less than or equal to 5, and f prime happens to be that difference quotient, we can then, by the transitive property, say the difference quotient is less than or equal to 5. You okay with that? Now we just plug in what we know. We know f of 0 is -3. So we get f of 2, which we're trying to find, minus -3 makes it plus 3, all over 2 is less than or equal to 5. And what we have now is this little linear inequality. If we can solve for f of 2, we'll have our answer. So we double both sides, and we get f of 2 plus 3 is less than or equal to 5 times 2, which is 10. Then we subtract 3 from both sides, and you end up with f of 2 is less than or equal to 10 minus 3, which is 7. And that gives you the same information, except it's done analytically instead of intuitively or graphically. 7 is the maximum value, and of course it could be anything less than 7, including a negative number, right? We could have gone from left to right with a negative slope, because that negative number is going to be less than 5. Okay, go ahead then and take 2 minutes and answer question 7b. This one here, if you try to think about it intuitively, is not as easy for a couple of reasons. First of all, we have the slope is -3 at a minimum. It could be anything bigger than that. And we have the starting value of f of 5 equals 2. We want to know what f of 1 is. So we're kind of going in reverse. So if you kind of drew it out, f of 5 is equal to 2. What's the biggest value it could be at 1? Well, you would want to come in not at the steepest slope, because at the steepest slope, you're going to have a positive slope, and that's going to make your value at 1 to be some negative number. So you actually want to come in at the minimum slope, which is -3, and work backwards to get the high value at 1. But maybe we don't even do it that way. Maybe we just set it up like this. We're talking about f of 5 and f of 1, so we know that f of 5 minus f of 1 all over 5 minus 1, since that's another name for f prime, right, because it's a differentiable function, that has to be like f prime greater than or equal to -3. Now, if you want to go ahead and put f prime here first, that's fine. That's the mean value theorem guarantees that. And now you can plug in. We know f of 5 is 2, so 2 minus f of 1 all over 4 is greater than or equal to -3. Quadruple both sides, and you get -12. So then you get negative f of 1 is greater than or equal to -14. And now when you multiply both sides by -1, what happens to the inequality? It flips, and you get f of 1 is less than or equal to 14. So the max value of f of 1 is what? 14, yeah. And it could be anything less than that. So you could have figured it out, but you would have to realize that you're going to come in at the minimum slope, not the maximum slope, and you're going to have to work backwards. So you're going to have to know to add the 12 instead of subtract the 12. Okay, so there's a nifty little application of the mean value theorem. Because it was differential, you can relate the average rate of change to the instantaneous rate of change. All right, any questions on example 7 or anything from the mean value theorem? I think your quiz on Monday is just going to be straight up kind of something like example 4. I'll have you do the mechanics. Does the mean value theorem apply? Yes or no? Why if it does? Why not if it doesn't? Then on a given interval, find the value guaranteed by the theorem. That's what your quiz tomorrow will look like. Okay, so go ahead then and download the notes for the next section.